we'll go over the methodology, and so kind of applying the things that you're learning as you go forward with, as you get familiar with the steps of creating a Wikidata account and then starting to do entries, manual entries, and the process of wanting to automate that as you work with larger and larger data sets. And maybe I'm a really good person for this because I've only been doing this myself for about a year. And so I feel like I've really learned a lot from Andra and Lynn and the whole group, Genewiki group. So maybe I'm a good person for people to ask. I think there was someone that asked about programming experience. And so yeah, myself coming from no background basically of having written a bot before joining this group, I can say that it can be done. And I initially learned how to do it in, I think, my first month of working in the group. And now there are a lot of things that I have learned in that process. So hopefully these will be helpful discussion points for all of you. And of course, if there's anything else that people want to add from their expertise, feel free. So why and when for creating a bot? I know that Andrea walked through a little bit of this already in the breakout, so maybe some of this is repetitive, but it's hopefully good to reinforce these things. So I'm going to give the example that I have mainly worked on, which is the ClinGen bot example. So here is my history, and you can see my name here with the account where I switched from basically my name and manually entering when it says 2019 of October, and then when I got it scheduled on the bot. So I think I formally got it automated into a bot form in November of 2019, and then you can see these updates with the protein box bot since. And here's the link to, again, the slides are in the Slack channel if people want to see this directly, but here's the link to where you can see all of our scheduled bots specifically for the Sue Lab and Genewiki project. So here's a bunch of them. Some of them are working, some of them are not, but here they are, and here's the ClinGen one here. And so going forward, why would you want to do this? Well, hopefully this is pretty clear, I think, by this point, but as opposed to, as you can see, and we'll go a little bit over this history, as you can see, as opposed to doing, maybe you just have quick things you want to edit here and there, and it's a quick fix that will take a couple of minutes, but then over time, as you get more and more data, then you're going to want to have that automated. So maybe if you have just a few entries that you're doing by hand and with your Wikidata account, maybe that will take you 10, 15 minutes to do those by hand. But then in this case, so you can see the most recent successful run, and you can click on this here, and it'll take you, so now you can see that it's not running very well, but there's another one running, and we'll go over that in a little bit. But this took a total of 24 minutes to run, and it's over thousands of data entries from the ClinGen database. And so what's happening actually is it's taking data from, we'll go over, from the ClinGen database, and then it's automatically updating that into Wikidata. And here's another example with Cellosaurus. So Andra is involved in this too, and so this is a tweet that includes Andra. But here you can see, it's over 100,000 entries that are now part of Wikidata. And, Lilia and wrote the bot, Andra did a lot of help. So basically, being able to write a bot, the first run of it takes a bit of time, but then it's much, much faster to do this and integrate whatever data sets you're interested in having be part of Wikidata than doing this manually, even maybe in your own research. And so with this example here, basically I wanted to show that this bot I originally started running, like I said, in November 2019 of last year. And I'd say there's been two main points where there's been trouble, and here's one of the other major points. And actually, so if I go back to this and we look and see, so anyone can click on this and see what happened. So this is, I clearly have to fix this, but if we look and we want to see what happened here, so this was the last, says last successful build versus the last build, and then I made a little output data file set, so I can share that with you too. If I can open this here, my downloads. So open this. Here we go. Let me share that with all of you. So I made this output file, which is, you can think, analogous to a log file. And that was just when I was starting to get familiar with the data. And you can see here, so this is the file that it makes every time there's a run. And of course, I'm going to be making some edits to this now. since I've done it, but basically if let me zoom in here so you'll see this a little bit better. Okay, so this file, basically I get my input file from the database looks a little different from this, and everything from here onwards is what I've added. So in my script, I set it up to walk through each of these lines. So here I have my gene, and then it kind of goes through, you know, which number it is, and I guess it's starting at 0 here, which is fine. But I give a note here if it worked or if it gave some error. So it's just binary as error or complete, and you can be more detailed with this. I've definitely done that. I think there's also some where I put updated. If I search here, wait, maybe it's not in here, or new right or something. Anyway, so I have my gene. Here's my GNC gene ID for that gene. Here's the disease name. Here's the Mondo ID here, Mondo ID. And then here's the standard operating protocol. And here's how it's inherited. This was the first time, I think in April or so, March or April, this was the first time I had a problem come up. And that was just because ClinGen added this column in their data set where there was only, I think, 9 before, and then there are 10, and now they've actually reduced it again. So that's that's why I'm having it not run anymore, or why it's not running anymore. But anyway, so going to this section, this is my output file to kind of help me debug what happened if there's an error. So it will say, so I have some criteria that I've put in here, and then I have this kind of confirmation of what the end QID is for either the gene or disease if it worked. And so you can see here, if it's an error because one of the criteria is it has to be a definitive gene, and then also it has to be definitive classification, and then also there's no QID for that disease. And so there's also things I put in there to write a disease. So it will create a page, an item page for that disease or for that gene if it's absent. But if it's a definitive classification, it won't write the rest of it. So here in this case, you can see it worked, and that's because there is a page for both of these, and also it's a definitive classification. So going back to this example, if I go back to the slides here, yes. So going back to this here, so you can see what happened. So the last time it was working well was early September, and I've been doing a lot of other stuff in that time, so that's why I haven't gotten around to it yet, but I will be soon. But if we want to see how this works, so it's like last unsuccessful build, last successful build. So if I want to see what happened in this last run here where it didn't work well, I'm going to go to console output, and probably Andre already went a little bit through this. So you can see that things are happening here. I'm walking through, the timer is started. I put a timer in my script, and it's connecting with a protein box spot, which is what we have to run the job for this bot. And then it's going through and it's collecting different things here. It's going through pip, cloning from the script from the GitHub, so that's over here. And then as it's going through and writing this, copying, etc. So okay, let's find the error that happened. Okay, so I'll always give you this output, and this is where you're going to find your error. So let's see where the error comes up. Here we go. Trace back most recent call. And so it's basically saying that here there's an issue with the number of columns and that's not matching up. So value error, length mismatch. So basically the new values have 9. So what this means is that ClinGen updated their input data set to be 9, and before it was 10. And like I said, the last time I had trouble with this, they had made it larger. So it went from 9 to 10, and now they've gone back and made it from 10 to 9. And so this will always happen, and you know, it's expected. Of course, you want to go and make your script as sustainable as possible, but these are things that are kind of outside of your control. And so you have to go back and adjust for these, right? And easy ways to figure out, so what does this mean for those who are new to programming, like myself? I did a lot of R before, and now this is all Python. So things you can do is you can just type in value error, and you can start to look in, okay, what does this mean for value error? So maybe this is repetitive for most people, but there's a lot of stuff that, and then it sends me an email too. So now it's saying that, okay, we emailed you to let you know. So I've basically been getting notifications saying, okay, I need to work on this. But I thought it would be a good thing to walk through as an example that, you know, something that can go good or badly over time, and kind of how to continuously work on that. And going back to this console here, so if we click back to this, So you can see these are the main bots we have going, and probably Andre already walked through a little bit of this in the breakout, but this one is running right now, and then they'll be in queue, so then it will try again. This is on a weekly schedule, and then it says here how much time it runs. It usually takes about 25 minutes for this one because it's not a huge data set. Okay, so going back here, so there's always going to be issues that you'll experience. So this is already a year out. I created this script for the spot and got everything together. I think it took me a total of 2.5 months, 2 months, having never run before. But once you get better practice, it probably will take you about a week or two, and then you're kind of getting feedback and going through the process. So what does that process actually look like? And also, as I'm going through this, please, feel free to use the chat to just ask questions freely, and I'll see those pop up, or if you want me to slow down, and I can go and walk through those as we're going forward. Okay. Any questions so far before going through this process of how I started to put this together and kind of the things that have happened since? Okay, so let me just do this. Get rid of these things here. Okay, so where and how to begin? So again, any questions up to this point? All right, so where I started, and I think again, Andre and Lynn have probably already commented on these things in the breakouts, but the main tools I use are Jupyter Notebook for just drafting my scripts, GitHub, because that's what our group uses is GitHub, and then community feedback, right? So a big thing that's been emphasized a lot throughout is community feedback, and and you'll kind of continuously go through this cycle. So I mean, me being the person that I am, I was like, okay, I'm going to get this done, I'm going to make a good impression in the group. And as I think Andrew has said, it's really that last 10% that ends up taking the most time. And it's totally true. The year after, there's still things that pop up, and that's fine. That's the nature of doing these automated bots. And really the community aspect helps a lot. So anytime we have meetings about once a month in the Genewiki group, and it's a really good space, really welcoming space. Both Lynn and Andra and others in the group are very welcoming, and it's a really comfortable environment to talk openly about things and get feedback, which I appreciate, especially during these times. Okay, so where did I start? So me being a total novice, I had not made a Wikidata account at all, so I might be in a similar place as where some of you may have started a year, where I was a year ago is maybe where some of you are starting now. So if I go to this history, I'll click here. So this is one example. And if you notice from the Excel, that was the very first one that popped up. So I'm already logged in here as Saba. So that's my account here. And you can see in this view history, so if we go again to the item, original item, you can go to view history, which I know might be a little repetitive here, but just to reinforce. So you can see where I first started doing things. So, okay, Andrew did something here. We had a bot over here. Now I've started to work in the Genewiki group. Andra probably helped with something here. And we can see exactly what those are if we want to. We can compare this and this, and we can just say, okay, let's compare these versions. And then we can see what exactly those were. Oh, I need to do a different one actually. We want to do, I don't want to do that, but that's okay. Yes, so you can see where I am manually doing things, Andra is manually doing things, Andrew's doing things, our bot is doing things. And then there's a switch, right? So then you can see here that I was doing a lot of stuff in October and September, it's very productive. And then I switched it over to it being automated. And so that's where the protein box bot takes off. And that's kind of where it's been happening now. So what's been going on? So anytime, this is basically doing updates to this specific gene. So if everything is fine in the script and this doesn't need any updates either on, this is the gene side or on the disease side, then everything is fine. So actually let's go to the disease side. So let's go here back to the item. So what is the actual thing happening? So I mainly worked on this section here. So that's what this bot does. The ClinGen bot that I have is just doing, looking at, okay, what's the disease association between the gene and the disease? And so in this case, one of them is Noonan syndrome, and you can see that that was put in here in 2019. I probably did that manually as a test, another one in 2019. Another one October 2019, and then where are the updates instead? And then here's the references. So I can then click to Noonan syndrome, and I can look at the history here. That's the association. So making sure that there's symmetry on both sides. So again, you can see the edits that I had, and then Andre did something, and then Protein Box Spot did some update here probably. Okay, so so first just walking through, and when I was first doing this, again, going back to that A2ML1 example, when I was first doing this, as you can see, I was doing it manually. So I would just edit something and I would just say, okay, state it in. I could make another reference here if I wanted, and I could say, you know, state it in my property. I'm going to do clin, and then it will autofill the rest. So maybe I want to do clinical try, whatever. I want to remove this because I don't want to mess this up. So I'm just going to do cancel. But that's an example of how you would write something in manually, which I think has already been, you've already walked through a little bit of that. So I tried that out manually, and I had this whole data set, I think at the time was around 600 rows or 600 entries. So 600 entries, meaning that there's a gene and there's an association. So about 1,200 max, if you think of symmetry, but probably less than that because there's repetitive scenarios between genes and diseases they're associated with. So I first just started to make sure that I understood the problem and I understood the data of what's going on. So I didn't really, my background is actually microbial ecology for my PhD. I did do biomedical research during my undergrad and a little bit in my master's, but it had been a little bit since I had familiarized myself with biomedical data. So first I needed to kind of look and see, okay, do I understand what these genes are? Do I understand what these diseases are and how they're being written, and you know what sources they're coming from and why they're coming from those sources, and the codes associated like HGNC and Mondo and things like that. OMIM was one that came up in our discussion. So just understanding what's going on and just exploring that a little bit by doing things manually. And there is a sandbox option where you can test things out in the sandbox, and that's also really nice and that's the advantage of using the sandbox option. Is nicer because then if you write something and you write it wrong by accident, then there's no consequence. In this case, you know, nobody else is really doing any of this except for me at the time, so it's okay. But realistically, you want to try stuff out in the sandbox, and then you can move it over because once it's published in Wikidata, you know, it's published and you have to go back and change that later. And maybe, you know, in the time that you're learning about stuff, you know, somebody uses that entry for whatever reason, but usually not, but it's a good practice to use a sandbox instead. And so because I was coming from a background of using R, so I was manually kind of playing with what these associations were and editing them and adding new ones just to make sure I understood how Wikidata functioned. And then I wanted to explore the data itself. So since I had this input sheet from ClinGen database, I took that, and this is a very messy set of figures, but just an exploratory analysis from my understanding of R. And you can look at this yourself if you'd like, where you can see kind of, and then I think this is also a GIF that I put here. So this is looking at the before and after of basically the before and after representing the criteria that I was trying to figure out of how I wanted to filter for what constituted in those 600 entries or so, what constituted as something that could be useful and something that that is not high enough quality or integrity for us to integrate into Wikidata. So then here's a little GIF that I made with R, just something cute, but it's a pretty messy figure, but just to show kind of where there might be biases in the data, either in the gene or disease level, and then also just like my own exploratory analysis. And so I have this process here, and this is my own, notice that this is my own personal GitHub, and then what we put in the scheduled bots is what actually ends up being loaded. So if we go to scheduled bots, and we go to ClinGen, it's just these very clean 2 files, the notebook, the kind of most recent or final notebook, and then the Python script. And whereas here, there's a bunch of different files, and this is kind of my own notebook process and workflow process, and continuously trying to be good about updating those. Okay, so now I've kind of manually tried things out. I've explored the data in the ways I can. So I usually did R. I knew R pretty well at the time, and now I do more Python. So going forward, I would do things in Python and keep everything in Python. And then starting to do tests of the Python script. So if we go to this site, so this is again one of the folders in my own personal repository. So you can see the process I have from September to November and the different stages. So it's, you can see this is the very first notebook, and I hadn't really done a lot with Jupyter Notebook until then. And so you can see Andra helped me with a bit of input. I had not even used Wikidata Integrator before, so you can see there's just a lot of things where I'm just kind of copying and pasting and not really knowing what's going on. Here's the QID, here's a property, I think for that association, gene association, and then here's my way to log in. And then you can see how different this is in the November 7th version, where this is set. You can go ahead and I encourage people to check out the drafts of this, but you can see now I have these things of checks or, tests or assertions, things that I still need to do. And then the main script, so here's all the process. Here's my kind of test set that I was working with to make sure things work. Here's the way I've been filtering things out. And then I have some functions defined. And here's my main for loop that I then end up making into the bot. And I have some pseudocode here of things I wanted to complete and fill out. And so then I got that to work. And then once that was working, that's when I got to the scheduled bots here. And this is the final script. So the notebook, the Jupyter Notebook is really used as kind of your test or your sandbox for yourself to try things and see that things are working, and then iterate through the entire data set once you've confirmed that things are really looking good for that small set. Because once you write something, right, if you're running a script on 5 things versus 100 things, and that's going to end up going to Wikidata, if you make a mistake that you might not see until later, obviously it's going to take a lot more effort for you to go back and fix all of those if it's more than 5 or 10 versus just trying out a little test or a subset data at first, and then getting that feedback from the community, and then making sure and trying the entire data set. And so here's the entire script here that runs. That's what the queue is in Jenkins that you saw when we were looking at the console output. Okay. And so, yes, and so this is, you can see that I was just doing a subset of 15. I think I started with 5, and then I would do 15, and then I would just move things over. So I would look for odd cases in my data from that first exploratory analysis I did. And then from those odd cases, I would try those out and see, kind of debug and troubleshoot as much as possible for then making a more holistic, sustainable script. And a lot of this came thanks to the feedback I received from Andra, Lynn, et cetera, from the Genewiki group. Okay, and then iterations from the feedback. So feedback, I can't emphasize enough how valuable it is, how valuable the community is. So here, Python, you can see in the script itself, Andra helped a lot with comments, Andrew helped a lot, Ginger saying also helped a lot, and I think I have a few other names in the final version. But these are the main checks that I had for myself, and then things to kind of continue. So even when you have a running bot and things are working, there might be still things you want to polish. And so there's always going to be a few small things, but you ultimately just want to have that base functional aspect. Is it doing the things you want? And is it making sure that it's not doing anything wrong? If it's doing something wrong, then that's a problem, right? So really working those kinks out as much as possible on the subset of data, and then trying out the rest. And so here are some of the things that I did, that I validated that these worked in my script. And then automating, so this is just kind of the first section of that script. Again, I already clicked on this from before, but you can see here, here's my notebook, and then here I converted my notebook over to just a full long Python script, and then I tried that out. I ran that first manually on, thanks, Thiago. I ran that first manually on my own computer, and then once we knew that that worked on my own computer, then we switched it over to the protein box spot. But of course, as you get more familiar, then you'll get through the process of how much you want to translate that over. Okay, and then overall advantages. So I think the main advantages here are just the transparency. So using Wikidata, using GitHub, and having this all available on GitHub. And maybe I'll fully admit that myself, had not ever done this before. I felt really nervous about the critiques I was going to get, and just like, oh my gosh, everyone's going to think I'm dumb, I don't know what I'm doing. I mean, people really don't care. Honestly, I feel it's more you're doing a service that's helping the larger community. And so if that interest is there and you care about certain data sets, I mean, that's really, people are going to appreciate that. And like I said, this group, the Genewiki group has been really, really encouraging. And, you know, there hasn't been a time where I felt dumb, even if there's been moments where I'm sure I've messed up and did something wrong that I should have done something else. And I think that process has been really critical to then encouraging and kind of incentivizing to this transparency, because, you know, you want to be able, basically Wikidata, we want to be able to set things up so that, you know, 2 years from now, 5 years from now, 10 years from now, if something comes up, we can more easily see what went wrong and we can address that. Just like with the, you know, my bot running and an issue running now, right, that I had, where's that Jenkins link? The issue of this running now, and, you know, being more transparent with my script, it makes it easier to identify where the issue went wrong. And so being as thorough and transparent with your script and your process as possible is not only going to help you when you're looking back and something does go wrong, but it's also going to help the larger community in the sustainability of the contribution of that bot script, or even your own work in the longer term. So definitely encouraging transparency, even though it can feel very bare, and you know, encouraging people to comment and encouraging to have that process be visible either through GitHub and or Wikidata of how that process looks over time and what the different changes are. And that it's totally okay to expect bumps, that you should expect bumps. You know, when I first did this in November, I thought of 2019, I thought, great, I did it, I'm done. You know, I don't have to look at this again. And you know, that's a nice thought, but also it's kind of a bad thought, because, you know, it's assuming that nothing is going to change, and things are definitely going to change. And so, you know, like I said, you can see here that I did this revision in January, February, because of the change with the, the change with the amount of data and the columns in the input data of the ClinGen going from 9 to 10, and then now it's again from 10 to 9. And in this revision, you know, I didn't just change it to be stuff from, okay, now let's just set up the parameters to read in 10 instead of 9. I also made a bunch of additional updates that I was meaning to do in that same revision. And now again, you know, here we are, September 2020, about a year later, and again, it's giving a problem, and that's totally fine. And also following up. So just because something works, it doesn't mean it did it the right way. So every couple of months or so, I check on these output files to make sure that they look good and nothing weird is happening too, because you can have these blue dots, or you can have something run and it could be doing something totally weird and wrong, and you don't want that either. So just kind of a summary of, you know, I'm continuing to learn a lot. I feel like Lynn and Andra are definitely experts here, and I'm sure they would also say that they're continuing to learn a lot through the process. So it's constantly evolving, and to not ever feel, you know, like you're a novice or an amateur, and that's kind of the benefit of having this community mindset. And so one of the questions that came up were the applications of this and the impact of this. So here are 3 main examples related to biomedical data. So here's Wikigenomes, Clambase, and Cytoscape as a Wikidata extension. And then there's also, for people that might do more R things, there's a plugin for the R that I haven't had a chance to explore yet, but I'm definitely curious for anyone that has. So these have been really impactful projects that have come out of people utilizing Wikidata for this purpose of integrating their data into Wikidata and then getting useful things out of that. And then an extension from that is the Sparkle queries, which I think was brought up in both of the breakout rooms, where then you can get to a stage where you have enough of these different types of data relations to different types of data and associations, and you can start asking questions and answering questions that you can't do just in those data sets alone through Sparkle, and kind of connecting lines that otherwise wouldn't even be possible or wouldn't otherwise even exist. So that's kind of the longer term impact. And with this specific example, there's ClinGen, but there's also a ClinVar bot that I'm working on, and then some other ones I'm going to start working on. And so the compilation of those different bots and how they have associations between genes and diseases in different ways, I can then start to build and put together Sparkle queries that are based on scientific questions I'm curious about and want to answer, which I can't do without Wikidata. And I guess with that, I'll wrap up. And are there any questions? Or general comments?
Yeah, thanks, Saba. That's really good. So I should put my... Hold on so you can see me. Yeah, that's a really nice overview, and maybe makes it slightly less scary to start working on the complexes, although I'm not sure about the time aspect I have available. Does anyone get like substantial funding to do this, or do you kind of do it as part of bigger projects and just squeeze a bit of time out of those projects to add the data to Wikidata and write a bot?
My position, so I'm a postdoc with Andrew's group, and then also partially a lecturer, but my position is fully funded to do this work. So I know that there are, so this is through the NIH, and then there's another grant I'm going to apply for, but it's through the parent grant that Andrew has, and we did a supplemental. So there's already funding available, and then I applied for a supplemental, and we got that too. So I was a little extra padding, and then there's another one. So there's a number of funding opportunities coming through the NIH as this becomes more and more important. And then I would defer also to Lynn and Andra to comment on how they've found good funding for these types of projects.
Yeah, our efforts are, sorry, I didn't turn my camera off. Our efforts are through R01 funding. So between Genewiki and Wikidata and the disease ontology project. We've had 2 rounds of those. And I think Andrew's in his 3rd round of the same R01. So yeah, there's some funding. There's not tons, but there's definitely some.
And there are also funding rounds that are not project driven, but small time fundings, where that coming from the Wikimedia Fund, from the Wikimedia Foundation itself, or going from Wikidata itself. But there are also out of the life science, outside the life science, I'm aware there is also a lot of projects going on in the GLAM space, which GLAM is an abbreviation for galleries, libraries, archives, and museums. So yes, it's scattered. I'm not aware. So it's scattered, but it's definitely going on. But there is also a lot of ad hoc use of Wikidata. We should check with the folks at Wiki Pathways. They are running, I think they're running BridgeDB, which is their identifier mapping service, which is completely running on volunteers. So it's just an extension to ongoing projects. So it's not being labeled as a Wikidata project, but part of research projects going on. And 2 years ago, we had a collaboration with the Reactome team where we wrote some bots as well, but that was also done outside of grant lines. So yes, it's a bit of both.
Yeah, and I think a lot of the translation work is done by volunteer groups too, groups that are engaged out there.
And yeah, and that's something where Andrew had a talk about, actually, let me see if I can find the talk while I'm talking about this. Andrew had a talk recently for Scripps. I'll find it and put it in the chat when Andra wraps up. But it's focused on crowdsourcing for kind of biocuration, and actually Ginger in our group spearheaded a lot of that. And it utilizes a lot, like people are really interested in these types of projects. And also people right now, it's a good time because, you know, well, I don't know if it's a good time, but a lot of people are wanting to learn skills because they are doing a lot of things from home. And so a lot of people are curious about learning programming or how to do these types of things, familiarize themselves with different types of technology. And so why not give them these opportunities to try and exercise that through these types of projects? I think generally people are pretty curious, and so you know you always have when you put a call out for a project, and I know there's different criteria depending on where you're located. Like in the U.S. we have IRBs for any time you involve people as part of your projects. You know, depending on the question, but generally you'll have, like, you know, a lot of people that will sign up when you put a call out for something, and maybe you have 10 to 15% of that original group that's really active, and that's totally fine, because that's still much more than if you didn't put that call out at all. And now you have people that are genuinely interested and they're learning something and they're getting something out of it personally, and you're also getting a kind of extra help on projects you're interested in. And then that's like a really good kind of two-way street, as well as you know, with all the stuff going on globally in the world right now, you know, it's nice for people to be connected to scientists in that way too.
Yeah, you were saying, I think Wiki Pathways, Egan said, they just got their first grant in many, many years that will actually fund some of this work, and that was piggybacked on a COVID application of some sort. But they've done a lot of stuff by either voluntary or integrating into other projects.
And we should also acknowledge a bit of an angle we actually didn't touch on, which I should maybe briefly cover. What Wikidata is also doing is that it is bringing linked data into the research infrastructure ecosystem. Because, for example, if you look at PubMed, I know that over a decade, various initiatives have been trying to get PubMed into a linked data platform. And now with projects like WikiCite, you see it moving forward. So Wikidata is actually not solving it, but by inspiration, you see, and I covered that a bit in the breakout, that about 2 years ago, it became a lot easier to deploy your own so-called quote-unquote empty Wikidata by deploying the Wikibase. So it's data, but it's also opening up the ways to use linked data in other platforms. I mean, the example that Saba gave on the ClinGen data, where the columns is a problem, and which might be a bit softened if, for example, ClinGen itself would start using linked data, because then you don't have to rewrite those mappings on a constant battle. So it's from it's a data provider, but also a schema provider and a way of building knowledge graphs.
Great. And I think with that, we are on perfect time for closing remarks, Andra. And I do have the poll ready for whenever you'd like people to do that too.
So give me a second. Okay. So going to the end of the time, it was great to have you all out here, and I'm hope to see you in the near future in the week. Wrapping up, I think we can, I already had this in my initial slide, the Wikidata is started as an extension to Wikipedia and can be wrapped up as what Wikipedia is to text and articles, Wikidata is to data. It works, it has the same as Saba has nicely showed, the same backend with respect to discussion pages, history pages. You can see you can see the total history, added history of a page. It is completely free, so the license, the Wikidata is available for under CC0. So it means it can be used in any context, even in commercial use cases. Anybody can contribute, both bots and humans. It covers not only the life science, so also museums, whether every kind of human society can be covered in. It's very it's scopeless. It integrates well with the semantic web, so it's stable. It has long-term support and is not dictated by funding cycles. But it's incomplete. But that's not a problem. It doesn't need to be. We're not trying to create the final solution, but since it integrates well with the semantic web, we can easily leverage links to other linked data sources in the same access and query languages that is already by using federated queries. And I would like to end with this nice XKCD adaptation that says surveys show that we have 16 competing. We should not try to create a 17th, but Wikidata can be the connecting hub or one of the connecting hubs between the 60. I wouldn't say Wikidata should be the only connecting hub. Here I have such a federated query. I won't go into details there, but we want interoperability. I will end up with for future reading. We recently did a bioprint preprint that is currently under peer review. This is our latest paper in eLife. This goes into describing schemas in a machine-readable format. Well, and by this, I would like to end this presentation and thank you for your time. Some final notes or questions we can answer. If not, I thank you for your time, and I hope to meet you either in person or on the Wikidata ecosystem in some or other capacity.
Yeah, thanks.